x is equal to 13 minus 165 over 23, all divided by 2. And it's late enough in the day that I don't feel like doing that in my head. I'm going to seek professional help. So I get about 2.913, which is apparently 67 over 23. Yeah. Tutoring in office hours. I have office hours 10 to noon, Monday through Friday. Yeah, you can. If you want to, you can try to Zoom call me if you want, I guess. But Zoom is really not a. Oh, I mean, technically, I know the operation plan, blah blah blah. You come to my office hours, and we'll go out to the Math Help Center. I'll write on a board. So, but yeah, we can in principle Zoom call, but. But the tutors in the Math Help Center downstairs, like they're not busy. Like you could easily go down there and ask questions to them for hours on end, and they'd help you. And they have a way of saying things better than I do for this material. Like they're much more experienced teaching this than I am. You got to understand, guys. I have done nothing but teach like calculus 1, 2, 3, differential equations, stuff like that for like a decade. It's been, 8 years or something since I've taught college algebra. And so like I am much less attuned to what you guys are suffering with as opposed to those tutors. They know full well. Like I don't even flinch. I go something like this to something like, so I go, 3x plus 8 equals x to 2x equals to minus 8. Like I just do that, I don't think about it. But I just lost you, right? Yeah. I lost most of you because there's like 2 steps between those, right? Don't ever write that again. I'm sorry, I'll erase it quickly. There. Anyway. But seriously, those tutors downstairs, it's very likely they're better than I am for like, if those kind of things are like in the way right now for you. But I do have office hours from 10 to noon. Okay, so let's move on here. So yes, the solution was much uglier than I'd hoped. Let me do an easier example. Example 3. No, I posted the solution, man. Well, now you know. Okay, so it's in course content. Okay, so in the Blackboard, which is a thing on the computer. Well, I told you about that realtor I was working with, right? He actually was looking for the Blackboard, like in the school physically. Yeah. He was not joking either. Anyway, so here, look, we didn't need to multiply by 2 or 3 or anything, right? This one, it's made to order. What should we do? How about add these equations? What happens when we add the equations? Yeah, the y's are going to cancel out. The y's cancel. We get 2x equals to? 6. X equals to 3. And what's y equal to? 0. Well, how about x plus y equals to 8? Tells me what? It tells me 3 plus y equals to 8. So that tells me y equals to what? 5. So the solution is 3, 5. See, these don't have to be hard. And how do we check our answer? Plug it back in, right? 3 plus 5 is 8. 3 minus 5 is minus 2. Got it. Another example. So there are really three methods to solve these. The one is elimination. The one is the adding equations thing I've just showed you the last two examples. And then the third method is just graphically. You can graphically solve. So example 4. Solve, let's say, y equals x plus 2 and y equals to x minus 2. So I'm going to take a graphical approach here. So x plus 2, x minus 2, so we got a slope of 1, like that. We got a slope of 1, like that. Right? So what's the solution? What would a solution mean? A solution would mean a point where the equations for both lines are true, which means there's a point of intersection. Is there a point of intersection? Do two parallel lines ever intersect? Right, not in Euclidean geometry. So no solution. Right? If we had subtracted those equations, what would have happened, by the way? Algebraically, if you look at, say this is equation 1 and that's equation 2, if you look at 1 minus 2, what do you get? Y minus y is 0, right? X plus 2 minus x minus 2, which, as you just told me, is 4. We get 0 equals to 4. What? That is not legit, right? There is, so we've seen already two cases. There's a unique solution that corresponds to when we have lines which don't have the same slope and they intersect somewhere, right? We could have parallel lines, and those would give us linear equations which have no solutions, no simultaneous solutions. And this will be our final example for today. Oh, you keep the quizzes. I don't want those. So my final example for today, example 5. Suppose we have 3x equals to 4y and 6x minus 8y equals to 0. So let's see here. We could rewrite 1. 2 times 1 gives me 6x equals to 8y, which tells... Mm-hmm.
Can you pull the 4 over, or take the 8y?
Oh yeah, you could, you're like, so what he was saying was, he wanted me to take that and say that 6x equals to 8y, and then probably you wanted me to say, so 3x equals to 4y, right? That would have been fine. But the larger point here is we can take one equation and manipulate it algebraically and to turn it into the other equation. So these equations are said to be what? These equations are what are called dependent. Dependent. So dependent equations are the same equation, just like rewritten. And so what does this look like graphically? Y equals to what? 3/4 x, right? Both this and that give me y equals 3/4 x, which is, just a line. What's the solution? This angered the other class when I told them. The solution is worse than that. Solution set equals to x, comma, 3/4 x, such that x is a real number. So the solution, or you could say that the solution is y equals to 3/4 x for any x. If you didn't want to write it with my set notation, if you just want to write it as a mathematical sentence, you can say that the solution is y equals to 3/4 x for any x. There's not one solution, there is infinitely many. This is the case when the lines are the same line and they just overlap. Did you guys have something right after class or something? Am I late?